Hello, I've created a baseball stat and I need help with it. The stat is called Matchup Plus and it's made to measure a matchup between any given batter or pitcher. This idea came to me when I was looking for a reason to hate on Bob Melvin and wanting an easy way to see if he was making the right bullpen decisions. I thought about how every MLB team definitely has a metric to find the best player to put in at any situation, but this knowledge is not really known to the public. I wanted to change that, so I wanted to try and make a website to see if I could do this. So, starting with my metric. Matchup Plus is the final stat that you get, but first you have to find a stat that I'm calling expected value. Expected value is exactly how it sounds. It is the expected value of the hypothetical at-bat that you have just set up. So, what you do is you assign each possible event happening in an at-bat. For me, I've gotten strikeouts, walks, fly ball, line drive, ground ball, and home run. Those are the 6 scenarios that can happen. You give a value to each of those scenarios, and then you multiply the value by the percent chance of it happening, and then you get a total expected value stat. So of course, the most important thing to know is how you find each of these percentages. I started off finding walk percentage and strikeout percentage because non-batted balls seemed much easier to handle. For all the percentages that I'm using in this video, for walk percentage, you find a simple average between the pitcher and the hitter. That's as simple as it gets, and that is about to be the core of where this statistic goes. For strikeout percentage, you get this as well. However, you add another factor called the whiff factor. The whiff factor is my way of accounting for a hitter's strengths matching up with a pitcher's strengths. To find the whiff factor, I get the average of the whiff percentage of the pitcher's best pitch and the hitter's whiff percentage against said pitches. Then I subtract 25, the league average whiff percentage, from this average to find how much the expected whiff wavers from the mean. This number I then divide by 2, not for any scientific reasons, just because I've thought it led to more realistic percentages in my testing. This means that when a hitter that tends to swing and miss a lot versus sliders faces a reliever that throws almost exclusively nasty air-bending sliders, the increased risk of strikeouts will be reflected in my model. Getting the walk and strikeout percentage was the easy part of getting the stat. Now I had to look at batted balls, which was a whole new can of worms. I'm about to throw out a lot of variables, so bear with me. First, I got a batted ball percentage. This is simply 1 minus the strikeout and walk percentages combined. This seems obvious, but will be important later on. Next, you find the batted ball rates. Notice that rate and percentage are 2 different things, and that is important for this. To find the percentage you will use in the final project, you have to add the 3 rates, ground ball, fly ball, and line drive together to create a batted ball rate, different from percentage. I'm sorry. Then, to finally get a percentage, you multiply the batted ball percentage by the percentage of the batted ball rate that accounts for each batted ball. Now, none of the words make sense, I know this, so I've very nicely, as I will this whole video, will have displayed all of the equations on the screen for you so you can follow along. Hopefully that's made sense, but this is just a very convoluted way to just make sure that all of the percentages equal to 100. Because I am creating this little pie chart, and for expected value to work, everything has to equal 100 because that's just how I think the probabilities should line up. So you now have all of your percentages. But you may have noticed that fly ball rate is read as raw fly ball rate. This has to do with the final percentage we need for our equation, home run percentage. Working under the assumption that the average fly ball rate is going to be about 10% all of the time, I first divided the raw fly ball rate by 10 before adding what I call the barrel factor. The barrel factor is pretty much the same thing as a whiff factor for strikeouts, but of course instead of whiffs, this is measuring barrels. For this equation, we obviously use 8 instead of 25 for the average because the average is different for barrels than whiffs. However, besides that, the equations are the exact same. This is my way of accounting for general home run / fly ball percentage over performance due to some people just hitting the ball harder than others or some pitchers just getting hit harder than others. It should be noted that This is also based on pitch barrel percentage, just like whip percentage, which further enforces the more pitcher-hitter matchup part of the formula. Then, to get the true fly ball percent, you simply subtract the home run percentage from the raw fly ball percentage. Now, you have all your values. This means that you can just plug it into the original equation, and bam, you have expected value. But you may notice that this video isn't called I made a website, it's called I made a stat. And that is because I cannot code. I've really tried, man. I took computer science 3 years ago and it did not help. I will tell you that I would love to have a website where you can yell at your TV for a decision the manager made. Go back and find a better matchup he could have played and then feel better when you're right, feeding your underlying ego where you think you could do a better job than that bum, Bob Melvin. On top of this, I think that in my website, I would like to be able to adjust the weighting of different stats. Because say, for example, your team is pitching in the bottom of the ninth, 1 out, down 1, runner on third. Your number one priority in that moment is to prevent a fly ball. So I wanted to make a tool where you can put the values of everything except fly balls to like 0. And then the pitcher with the lowest matchup plus against the hitter would be least likely to give up a fly ball and therefore the correct chase in that situation. This allows the matchups to also adjust for the situation and what the user of the website prefers, what they want. I think that it adds depth and value to the tool and really just makes it even more than what it originally was. But as I previously mentioned, I cannot code. So I need someone watching this to hopefully be inspired to want to take action on this project. So if you see this and you are any type of interested in helping me out, drop a comment below and I would love to work with you. It should also be noted that I tested it out, and obviously I can't normalize it yet to get matchup plus, but the expected values I got felt pretty real, so I think the stat should hold on no matter what the matchup. Hello, this is me from the future. The video was going to end here, but then I realized that I forgot the most important aspect of the stat because I'm a big dumb idiot. So to actually find matchup plus, which is the whole point of this video, and I just somehow omitted it, but to find it, you just normalize expected value. To do this is relatively simple. All you do is divide the expected value you got by the average expected value and then multiply that by 100 and boom, you have matchup plus. This means that any matchup that is exactly 100 is a completely average balanced matchup between the pitcher and the hitter. Anything less than 100 would be pitcher favored. Anything more than 100 would be hitter favored, the exact same way that all plus stats work. That's all I got for y'all. I hope you very much appreciate this video. I appreciate you watching this video. And please, please, please let me know if you can help me out. Bye-bye.